record this because there was at least one person who is unable to join us today. So we're going to review linear functions, and this actually goes back to grade 9 and 10. So a lot of this will be distant, faded memories. We're going to review how to determine the equation of a linear function if we know the characteristics of a line. We're going to be interpreting slope as something called a rate of change of y with respect to x. And then I've thrown in something else, which is that you're going to learn how to use your calculator to analyze data, which comes in handy in this course. A linear function is any function of the form f of x equals mx plus b. The graph of a linear function can be written as y equals mx plus b. And I say it in two statements there because some people think a function is a graph. A function is not a graph. A function is a relationship between variables given in an equation form. But you can visualize that relationship. You can visualize that pattern by looking at the graph. And if you do graph a linear function as y equals mx plus b, m is the slope, and the y-intercept is b. If you ever know 2 points on a graph, and I'm calling them A and B on this picture that you've got in your notes, if you want to find the slope, you take rise over run, delta y over delta x, and it's found by taking the y-coordinate of one point minus the y-coordinate of the other over the x-coordinate of one point minus the x-coordinate of the other. I think it's important that you understand, I'm sure you do, you cannot take the y-coordinate of this and subtract the y-coordinate of that and then divide by the x-coordinate of this minus the x-coordinate of that. You have to subtract in the same order. Okay? So we typically write y2 minus y1 over x2 minus x1. This is a formula that would be given to you in grade 10 math. It's expected that you know how to find the slope without the formula in Math 31. The slope of the line can be thought of as the rate of change of y with respect to x. What does that mean? It means that if the slope is 5, y changes 5 times more rapidly than x does. It means that if x goes up by 1, y goes up by 5. It means that if x goes down by 3, y goes down by 15. You have to think of the slope as being a rate of change of something with respect to x. Now, in order to determine the equation of a linear function, there are many ways that you can do this, and your grade 10 teachers probably taught you at least 2 or 3 methods and focused on 2 of them. But I want to focus on the third one all the time. The way that we want to find the equation of a linear function is by using this formula. And back in grade 10, this is called the point-slope form of a linear equation or function. I refer to it as a point-slope formula. It's a formula you use to determine the equation of a linear function. Why is it called the point-slope form? Because m is the slope and x1, y1 is a point on the line. Make a note to yourself that in this equation, x and y are not numbers, they're variables. What's x? It's x. What's y? It's y. Everything else is a parameter or a number. And line, this is just a quick review. If you have a line which falls to the right, we always, when you look at lines, everybody, we always think left to right on a graph. If you have a line which falls to the right, it has a negative slope. So a line that looks like that has a negative slope. The slope is negative. A line which rises to the right has a slope that's positive. A line that is horizontal has a slope of 0. And a line that's vertical has a slope that's not defined. What does that mean? It means it's infinite. I mean, if you have a really, really steep slope, you go over a little bit for x and you go up a lot. Here, you don't even have to, with a vertical line, go over at all. You go up infinitely far, just based on the fact that the line is vertical. So example 1, determine the equation of a linear function whose graph passes through these 2 points. So since I'm telling you that this is the equation I want us to always use, your goal is to find 2 things. Your goal is to find the slope of the line and identify the coordinates of a point on the line. Well, a point on the line is 4, 6. So this is x1, y1. 4 is the number we put in for x1. 6 is the number we put in for y1. Now, we also need to determine the slope. But the slope can be found using our slope formula. There are other ways to find the equation, but I want us to do it this way. So this is our goal over here. This is what we're after. Because if we can determine both of these pieces of information, we can load them into the point slope formula. And by the way, it doesn't matter which point you choose. If the line passes through both of these points, we could use 4, 6 for x1, y1, or we could use 2, -4. I'm not going to do this, but if you do it using the other point, you get the exact same equation in the end. So what's the slope equal to? Well, the slope will be y minus y, 6 minus -4, over x minus x, 4 minus 2. It's been a long time since you've done a slope calculation, like over 2 years probably. But I'm just looking up at these numbers and I'm taking y minus y over x minus x. And we work out what that is, and on the top we get 10, and on the bottom we get 2, so the slope is 5. It's a pretty basic question so far. The slope is equal to 5. So now we can get back onto the main road and use our point slope formula to answer the question. So I'm going to have y minus y1 equals the slope times in brackets x minus x1. So as far as things go, that's an answer to the question. That is an equation relating x and y. However, we don't usually leave it in that form. I would multiply the 5 by the x and the 5 by the -4. And then you can either write y equals 5x minus 14. How's my arithmetic on that? Good. And that's called the slope-intercept form. We really like to have what's called, I can never remember. It's not important. I think it's called the standard form or the general form. It doesn't matter. We really like to have it equal to 0. And there's a reason for that. So I'm going to explain the reason why we prefer this. And then I want to show you one other thing before we move on. The reason why we prefer that is if you set it equal to 0, you can always get rid of fractions. If you get a line, you get an equation of a line that's y equals -3/11 x minus 2. Because not all lines come out with a slope that's integral. That's a whole number, positive or negative. You can write it in in slope-intercept form, which is this, or first of all, when you zero an equation, we want we always write the x, then the y, then the number in what I'll call standard form. And we prefer it if the x's are positive. You don't want negative x's, so I moved them to that side. The nice thing about this is since it's equal to 0, I can multiply everything by 11 and get 3x plus 11y plus 22 equals 0, and I don't have to deal with fractions. So this standard form or general form, whatever it's called, is preferable. All right, for the above function, if x is decreased by 7, then how does y change? Well, your slope is 5. Slope was 5, yes? And slope is delta y over delta x. If I give people this question, even in grade 10 or 11 or prior to this course in grade 12, they can figure it out, but it becomes a puzzle to them. They end up drawing a graph and counting squares and doing all kinds of things. Whereas when you say x is decreased by 7, you're telling me delta x is negative 7. Delta means change. So the change in x is negative 7 because it changes by 7 and it decreases. All we have to do to answer this question is put in negative 7 for delta x, and we can cross multiply or multiply both sides of that equation by negative 7 and get delta y is negative 35. So if x is decreased by 7, y is decreased by negative 35. And you could probably reason that out. One thing that I would tell you at this level is really important for math and solving problems is you want to do things algebraically rather than trying to puzzle them out. Rather than going, I wonder how I could figure this out. You want to use algebra because there's too many different puzzles otherwise. Any questions with example 1? All right, example 2, determine the equation of a line that's perpendicular to 3x plus 4y minus 10, and it also passes through the point 2 comma negative 5. Okay. So we want to find an equation. And that means we need to know the coordinates of a point that the line whose equation we want to find passes through. And we do. It's 2 comma negative 5. If you parse this language, this sentence in English, it says determine the equation of the line, comma, there's no comma there, but we could put one, perpendicular to this, end comma, passing through that point. So this piece of information that I'm crossing out is still important. But when you read the English of that, it's saying determine the equation of a line that passes through 2 comma negative 7. It passes through that point. Now the line we're after also is perpendicular to that line. And you need to remember here that parallel lines have equal slopes. Perpendicular lines have negative reciprocals as slopes. Let's just pull off the road for a second. If I told you that line 1 is parallel to line 2, and I told you the slope of line 1 is negative 3/4, then that means the slope of line 2 is negative 3/4. That's common sense, isn't it? Kind of. I mean, parallel means they're not going to meet, so one of them is not steeper than the other. They have the same steepness. What does it mean, though, to say that perpendicular lines have negative reciprocals as slopes? If line, we'll say 3, is perpendicular to line 4, the slope of line 3 is negative 3/4, then the slope of line 4 is the negative reciprocal of that number. By the way, it just occurred to me that these numbers I'm choosing, negative 3/4, might be the same numbers in this question, but if they are, it's a total fluke. Okay, I'm not trying to send a message about this particular question. I should have chosen negative 8/41. Okay, it doesn't matter what the numbers are. So What does that mean? It means that whatever the slope of this line is will lead us to what the slope of this line is. It's a little confusing. So how do we find the slope of this line? We rearrange it. It's negative 3/4. Just by fluke. I did not intend that to be. We rearrange it for y. And the reason we rearrange it for y, divide everything by 4, 10 over 4, not that it matters. 10 over 4 is 5 over 2. We don't really care about that anyway. What we care about is this. The slope of this line is negative 3/4. That's not the slope of the line we want to find the equation of. That is the slope of the line that the line whose equation we want is perpendicular to. And again, that's confusing. Like, to put it into words is very awkward. What this means is, since the line we want is perpendicular to this line, the slope of the line we want is the negative reciprocal of that line. So far, so good. Any questions? So what do we do with this now? This was just, we don't need this inside of this corner anymore. That was just so we could determine the slope. What we do with these two things now is we load them into y minus y1 equals m x minus x1. That's always what you're doing when you're trying to find the equation of a line. Well, anytime I say always in this course, you know there's bound to be exceptions to every rule. All right, what does that give us? It gives us y minus negative 5. Now, if you just watch carefully, don't write, but just watch and listen. This is what I do. I go y minus negative 5. I'm not going to write y minus negative 5. I'm going to write y plus 5. Equals the slope, which is 4/3, times x minus 2. Now, we have these two kind of popular ways to write linear equations. I've already explained in the first example that this form, which is called the slope-intercept form, can be clunky because we're going to have fractions. What I'm about to show you is not what we would do here, so there's no need to write down this next little bit of business. If you multiply this through, like we did in the first example, you're going to have y plus 5 equals 4/3 x. And now you have to think about fractions. 4/3 times negative 2. I mean, I hope that everybody understands when you multiply fractions, you multiply across the top and you multiply across the bottom, and you get negative 8/3. Are you with me on that? So now it becomes even more difficult, because what you have to do, if you're trying to get this, you have to subtract 5. You got negative 8/3, and now you have to subtract 5. It's not insurmountable. We can figure it out. I believe you're going to get negative 23/3, because 5 is 15/3. But this becomes, it's not, like I said, it's not insurmountable. It's not something we can't do. But simplifying this is a bit of a, just something we would rather not do. So I told you we're not writing that down. What we're going to write down instead is a wiser, smarter way of cleaning this up into an acceptable equation. And it's to simply multiply both sides of the equation by 3. So I'm going to get 3y plus 15. Now, when I multiply the right-hand side by 3, the 3 cancels with the 3 on the bottom of the 4/3. And I'm left with 4 times x minus 2. A common mistake that I've seen people make here, excuse me one second. A common mistake that I've seen people make here, and I hope that nobody watching or in the room makes this, but if it makes sense to you, then you need to understand it's wrong, is to write, instead of 4 times x minus 2, go 4 times 3x minus 6. Because they think they have to and you have to multiply everything by 3. You do. But because there's a multiplication in here, you don't distribute that 3. Do you get my drift here, what I'm saying? If I told you to, the example I've used for years is I say multiply 3 times 4 times 2. You get 24. Right? You don't go 3 times 2 is 6, and 3 times 4 is 12, and 12 times 6 is 72. You don't do something like that. You just go 2 times 3 is 6, times 4 is 24. Or you go 2 times 4 is 8, times 3 is 24. All right, we're just about done. I suspect many of you here would have skipped this step and just written 3y plus 5 equals 4x minus 8. Because looking ahead, you know that 4 is going to be distributed through. Yeah. Thank you. I think I might have said 15, but my brain slipped a gear there. It is 15. Thank you, Cambry. And now, I mean, we don't have any fractions. The purpose of multiplying everything by 3, both sides by 3, is to eliminate the fractions. I'm going to write this now as 4x minus 3y minus 23 is equal to 0. And I hope that you appreciate, even though I moved everything to the right side, there would be nothing wrong with me doing that. In fact, that's probably what I would write. I tend to say equals 0, whether I'm moving stuff to the left or the right. Questions with that example? All right, we have, I believe, one more example to do, and this example is only in the notes because we're going to need to know how to use our calculator for the next lesson. So what's going on here is a biologist is doing a study on the feeding behavior of a group of birds. He or she, I guess it's she, sets up a bird feeder that shows the amount of bird feed in, well, cubic centimeters, I guess. She fills it with 10 liters, and a liter is 1,000 cubic centimeters. So you can see she goes into the clearing, and at the beginning on day 0, she scares all the birds away. She fills it up to 10,000. She leaves, and then maybe she's got a camera because she doesn't want to interfere in her experiment. And she's looking on her webcam every day at 24 hours afterwards. At 2 o'clock every day, she reads the level on the bird feed and how much is there. And it should be no surprise that it's going down. Right? Birds are eating the seed. It says determine the equation of the best fit function. And I want you to notice, particularly for those of you who have taken Physics 30, that this doesn't say linear function. I believe it is going to be linear, but it doesn't have to be linear in this course. So how do we determine the equation of this? Well, you could take a piece of graph paper and plot all of the points and draw a straight line and find the slope and the y-intercept, or you could use the technology that's available to us. And your graphing calculator I had a good conversation with my niece, who's like 30 years old now. She's been out of high school for a long time, and she says she can't believe that this is still the graphing calculator that people use. And I'm telling her, and I'm telling you, this is the best graphing calculator, or a TI-84. The reason why these calculators are still around and they haven't changed is nobody's come up with something that's better for learning math. Yeah, you have voice-activated programs in your phone that will do all kinds of math, but you will not learn anything from them. This is a great learning tool. So what we are going to do, we're going to prepare this by clearing our calculator memory first. Not clearing our calculator memory. By going to y equals and making sure there's nothing in there. We don't want anything in there. So make sure there are no functions. Then what we are going to do is go to stat, which is 2 keys over from the alpha key, and then choose edit. Now, I don't know what's going on in my calculator. I have some numbers in there. Let's say that you're doing this and you have numbers in these 2 lists, or these lists, and you want to get rid of them. The best thing to do is to go to the same place you go to reset the calculator memory, mem. So you go second plus, and you choose clear all lists. Okay. Just want to check. You didn't take physics 30, eh? Okay. Aiden, did you take physics 30? No. Okay. So now we go back to stat edit, and the golden rule here, everybody, is your manipulated variable or your independent variable, which means x goes on the horizontal axis and goes into L1. What we want to do here, everybody, in case it isn't clear, the graph that is going to provide us the most meaningful information is one that has the volume as a function of the day. I guess she's calling this n. This is going to be the thing that is most meaningful. So we need to enter the day number in for L1. X goes into L1, and the volumes into L2. So 0, it looks like she's only checking every 2 days. And because we're going to do something with the calculator where the calculator crunches all of these numbers in a minute, you want to make sure that you've entered them in correctly. We're okay. Clearly, these are ordered pairs, which means you have to put them in the same order. You have to put the 10,000 with the 0. And then 9380, 7920, 7530, 6910. I'm just saying them out loud to keep my mind focused. 5170, 4250, and I'm going to double check all of them. 10K, 9380, 7920, 7530, 6910, 5810, 5170. I think mine are okay. Hopefully yours are okay. So now for those of you that have taken physics, there's something we have to do here that we wouldn't do in physics. We have to find out what kind. Did you take physics? You did, yeah. We have to figure out what kind of relationship it is. Maybe it's linear. Maybe it's exponential. Maybe, heaven knows, it's logarithmic. We don't know until we look at the graph. So what we're going to do is a number of things. We're going to set up our window setting to match these numbers. Our x goes up to 14, so I would probably go from 0 to 16. I'm going to go up by 2. That x scale just means it's going to put a tick every 2. My y, you don't have to start at 0. I'm probably going to change those 2 zeros to other numbers in a minute in retrospect, but my biggest is 10,000, so I'm going to go up to 11,000. and we'll go up in increments of 1,000. Um, if I hit graph right now, I'm not going to see anything, by the way, but if I hit graph, then my axes are wedged right in the corner of my window. And sometimes I might want to see a little bit of room below the horizontal axis and to the left of the vertical axis. And I can accomplish that by, instead of going from 0 to 16, maybe -1 to 16. We need to be savvy and crafty enough to know that you don't have a negative n in this domain. You can't have a negative day. You're not traveling backwards in time to find out what happened yesterday. And I might, instead of starting at 0 here, I might go -500. I just like a little bit of air. So now when I look at the graph, I can see on both sides of the axis. So now how do we get the data to show up? Well, when you have an equation of a function, you go to y and enter the function. When you want to plot data, you go second y to create a plot rule. So if I choose second y, here are my stat plots. I have stat plot 1, 2, 3, 4. I have 5 different, well, I only have 4 different plots on my calculator. You'll notice that they're all off. So I want to turn one on. I'm going to hit enter to go inside of the settings for plot 1. I'm going to hit enter again, and now it's on. In any high school course, I don't know why you would want to use any of these other plotting features. If the curriculum changed, we would, but in the current curriculum, we wouldn't. We just want dots. And I prefer the squares rather than a dot or a cross. The squares are more visual. So now when I hit graph, I can see it. And I hope that everybody can appreciate that we use mathematics a lot of the time to model the real world, but the real world doesn't follow a perfect mathematical pattern, right? So when we look at this, and I've asked students this before, I go, is it linear? And people go, no, because it's not perfectly straight. No, it's linear. As far as the biologist is concerned, that's pretty darn linear. In fact, if it weren't for that one really, really hungry bird on day 2, that data point would be up a little higher and it would be almost perfect, right? But it's not a scientist's or a mathematician's job to say which data is important and which isn't. It's all important. So what now? Well, there is something called regression in mathematics. And regression is a way to determine the equation of a relationship if you have data. So since we've learned that this is linear by looking at it, we're going to do a linear regression. You go to your stat menu, then you go over to calculate, and you choose the regression that you feel fits the model that you're looking at. And I think the model is linear. And I'm sorry, I'm going to quit out of here. You have to be at your home screen. I think I hit graph there by mistake. So you go to your home screen, you go stat, calc, linear regression, and hit enter. Now, if you have a TI-84, the platform is a little different, right? You click through step by step, and then it calculates it. But that's straightforward. So this is the equation of the line. And by the way, if you wanted to graph this, this is not a big deal. But if you wanted to graph it, you can go to Y. And while you're there, go stat. Nope. While you're there, go vars. Statistics. It's been a while. Equation, which is the regression equation, and it will type it in for you, or you could just type it in yourself. The point is, if you put it in for Y and you graph it, would you say that line fairly represents the feeding patterns? Okay, then it's fair. It's good. If you did a quadratic, it would draw a parabola through there, but it wouldn't match. So your calculator is only as smart as you guide it. So what's the equation? The equation is that the volume of bird feed is negative 406.5 times the day number plus 9965. Those of you that have taken Physics 30, you will recognize what I'm about to tell you here. This should be 10,000, shouldn't it? I mean, it should be. That should be the y-intercept. But it's not, because the equation we're getting is an experimental summary of all of the days. So it's like an average. What does this mean? The most important thing is that the slope is negative 406.5. 406.5 what? Dollars? Bananas? Well, it's rise over run, and the rise is cubic centimeters. The run is days. So the slope is a rate of change of the bird feed with respect to the day number. In other words, the birds are eating, averaging out, 406.5 cubic centimeters of feed every day. I think it's just an interesting question. I came up with it, though, primarily so that when we do an example in the next lesson, it's not even going to be in the next lesson. It'll be like Thursday or Friday. You will understand how to put this data into your calculator. Okay. We're done reviewing right now.